Next problem. Find the distance from the point 1, 2 to the line 5x plus 12y minus 3 equal to 0. We know the distance from a point to the line, right? Point x1, y1 to the line ax plus by plus c equal to 0 is the distance d is equal to ax1 plus by1 plus c by root of a square plus b square. So given line 5x plus 12y minus 3 equal to 0. Here a is equal to 5, b is equal to 12, c is equal to minus 3. And x1, y1 is the point 1, 2. Therefore the distance, required distance is d is equal to 5 into 1 plus 12 into 2 minus 3 by root of 5 square plus 12 square, which is equal to 26 by root 69, 26 by 13, that is equal to 2. Next problem. Find the distance between two parallel lines 3x plus 4y equal to 12 and 6x plus 8y plus 1 equal to 0. We know the distance between two parallel lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is d is equal to modulus c1 minus c2 by root of a square plus b square. See, both the lines are ax plus by plus c1. Here also ax plus by plus c2, only constant term differs. So you have to change the given equation into the standard form, right? Given lines are 3x plus 4y equal to 12 and 6x plus 8y plus 1 equal to 0. So now 3x plus 4y plus 12 becomes 3x plus 4y minus 12 equal to 0. This is the standard form, right? Then the second equation 6x plus 8y plus 1 equal to 0. So take that 2 outside because ax plus by in the both equations, right? So similarly here 3x plus 4y, change it to 3x plus 3y in the second equation. So take 2 is common. 2 is common for 6 and 8, right? So you take 2 outside, so 2 into 3x plus 4y. So 1 becomes 1 by 2, right? So that is equal to 0. So the second equation is 3x plus 4y plus 1 by 2 equal to 0. So a equal to 3, b equal to 4, c1 equal to minus 12 and c2 equal to 1 by 2. Therefore the distance is minus modulus minus 12 minus 1 by 2 by root of 3 square plus 4 square, that is equal to minus 25 by 2 by root of 25. So 25 by 2 by 5, that is equal to 5 by 2. Next problem. Find the value of k for which the lines kx minus 5y plus 4 equal to 0 and 5x minus 2y plus 5 equal to 0 are perpendicular to each other. So given kx plus is 5y plus 4 equal to 0, first equation, and the second equation, both are perpendicular, that is equation number 1, equation number 2. We know the slope of the line ax plus by plus c is m is equal to minus a by b. So slope of 1 is m1 equal to minus k by minus 5 and slope of 2, right, is so minus cancel, so m1 equal to k by 5. Slope of second equation is m2 is equal to minus, because ax, right, minus 2y, right, so minus 5 by minus 2, so m2 is equal to 5 by 2. So we know for the perpendicular line product of slopes equal to minus 1. So m1 m2 equal to minus 1. Therefore k by 5, 5 by 2 equal to minus 1. 5 and 5 numerator denominator 5's are cancelled. So k by 2 is equal to minus 1, k is equal to minus 2. Next problem. The line A minus 2 comma 3 and B 4 comma B is perpendicular to the line 2x minus 4y equal to 5. Find the value of B. So the line, we know slope, 2-point form of the slope. The slope of the line passes through the point x1 y1 and x2 y2 is given by m is equal to y2 minus y1 by x2 minus x1. Here x1 y1 equal to minus 2 comma 3 and x2 y2 is equal to 4 comma b. So slope of that line passes through the point A, B is given by m1 is equal to b minus 3 by 4 minus 2, that is b minus 3 by 6. We know the slope of the line ax plus by plus c is minus a by b. So slope of 2x minus 4y equal to 5 is that is m2, right? Minus 2 by minus 4, that is 2 by 4, that is equal to 1 by 2. m2 is equal to 1 by 2. So we know the for the perpendicular line, product of the slopes equal to minus 1. m1 m2 equal to minus 1. So b minus 3 by 6, 1 by into 1 by 2 equal to minus 1, because the line through AB is perpendicular to the line 2x minus 4y equal to 5. So the slope line through AB, that line slope is m1, correct? m1 equal to b minus 3 by 6, and the perpendicular line 2x minus 4y equal to 5, that line slope is m2, that is equal to 1 by 2. So b minus 3 by 6 into 1 by 2 equal to minus 1. So b minus 3 by 12 equal to minus 1. b minus 3 equal to minus 12. Therefore b is equal to minus 9. Thanks.